This article is titled Flexural Behavior of Delta and B Delta Cold Formed Steel Beams, Experimental Investigation and Numerical Analysis. Contributing authors Yazid Hadidan, Nadia Qwider, and Mohammed Ben Zarar. This study summarizes the behavior of cold formed steel beams subjected to 4-point bending with lateral restraints. An experimental study plus numerical models were developed. Plus the notion of effective weight for class 4 sections according to Eurocode 3 have been taken into consideration. In this figure, the cross sections of cold formed beams delta and B delta. This table contains the geometrical properties of models. Theoretical study. The properties of the effective cross sections class 4 are based on the theory of the method of effective weight designated by Eurocode 3. The measuring equipment for the experimental study is composed of 3 comparators for the measurement of the displacements. The deformations are measured with the help of the gauges glued to the upper and lower flange in the web. The mechanical properties of the steel material are identified by the tensile testing of 6 specimens. Numerical study. The choice of the ABAQUS software is thanks to these great performances in the numerical nonlinear analysis. The A2 gauges shows the large deformations are in the upper and lower flanges. The A1 gauges presents a negative deformation. The delta beam showed great displacements, especially concerning the middle comparator C1. A very good correlation between the numerical results experimental and those proposed by the Eurocode 3 Part 1-3 have been on the class 4 cross-section, a difference of less than 5%. The numerical results confirm that the B delta beam has a maximum moment capacity compared to the delta model. Failure mode in delta beam. Failure mode in B delta beam. This study allowed us to see the real behavior of the cold formed beams. The FEA predictions are generally in good agreement with the experimental and theoretical analysis. Buckling of the compressed upper flanges in the web. For cold sections, when the concept of thinness appears, local buckling of the compressed walls must be considered. Absence of distortational local buckling thanks to the lateral support system.